Okay, stats, we're continuing 3.4. We had just done the interquartile range and what it means. When we were first doing measures of central tendency, we talked about how the mean was less resistant and the median was more resistant because outliers don't affect the middle number very much, but they can affect the average a lot. So to illustrate this, the mean and standard deviation are both affected greatly by outliers. The median and interquartile range are not so much. So suppose the 15th car travels through the construction zone at 100 miles per hour. I think we can assume that would be an outlier. In fact, 100 miles per hour is almost an outlier on any road. How does this value impact the mean, median, standard deviation, and interquartile range? So the median, or the mean without the 15th car was 32.1. With it was 36.7, so it was increased almost 5 miles per hour. The median, though, only went from 32.5 to 33. It was hardly increased at all. The standard deviation went from 6.2 miles per hour to 18.5. And you have to remember on that standard deviation calculation, remember we took a number minus the average and then squared it. So of course this thing is going to go out of control. The interquartile range only went up 1. Not so bad at all. So again, generally, if the distribution is symmetric, then there's not that many outliers and you can use the mean and standard deviation. If the shape of the distribution is skewed, the mean and the standard deviation are going to be badly affected by outliers, so you'll use median and interquartile range. This is one of the reasons we hear things like median family income. It's a better, more accurate measurement. You don't want Jeff Bezos offsetting like half the population of the country because of how much money he makes, because that just makes everyone feel bad about themselves. So that's why we use median. Okay. How do you know if something's an outlier? Well, we have a mathematical way to use our interquartile range to check it. So checking for outliers, first you need to find the first and third quartile. I'm going to go ahead and put those in because we had them from before, 28 and 38. That means the interquartile range was 10. Determine the fences. So what is a fence? A fence is a cutoff point for outliers. You're saying how far past the interquartile range can I go and still be, like past my upper and lower quarters and still be reasonable. And that's generally been determined to be 1.5 times the interquartile range below the quarter 1 and above quarter 3. So let's look at that. 1.5 times 10 is 15. 1.5 times the interquartile range. So that's the number that'll get added and subtracted here. So 28 minus 15 for the lower fence. Lower number minus 15. Upper number plus 15. So that means my lower fence is 13 and my upper fence is 53. But what does that mean? That means any data values that are less than 13 or bigger than 53 are outliers. So this is looking at the numbers. Are there any outliers? So unless you're counting the 100 miles per hour, which I'm assuming we're not because we're using the data from the previous one, there are no outliers. And that's it for 3.4. So let's just go ahead and roll into 3.5. So 3.5 is a 5-number summary and box plots. Now, the 5-number summary is just where you give 5 numbers to represent data, and those 5 numbers are the lowest number, the first quarter, the median, the third quarter, and the largest number. So the number of fish caught in a tournament by 11 people, find the 5-number summary. Well, we know the minimum. We'll just drop it. You know the maximum, 63. So we need to find the middle number. The middle number, it's odd, so there'll be an exact middle number, should be this one. Now, if you use the middle number for The median, remember we talked about when you had to average numbers, they both get included. When you use the middle number, you need to take it away for doing your other two groups. So the other two groups are the same size. So find my quarter 1, I find the middle number of the lower group, which looks like it's 49. And for Q3, I need to find the middle number of my upper group, which looks like it's 60. And there's your 5-number summary. Not that difficult to do. Now, people take this 5-number summary and can make a visualization of what's happening. It's called a box plot. So to make a box plot, you determine the lower and upper fences, draw a number line long enough to include maximum and minimum values. It says insert vertical lines at Q1M and Q3 and enclose these in a box. Label the lower and upper fences. Draw a line from Q1 to the smallest data value that is larger than the lower fence. Draw a line from Q3 to the largest one. Any data values that are lower, that are outliers, you just mark them with asterisks. Well, what does that mean? Okay, let's go down to the number line at the bottom. We had those same pieces of data, right, from the last page. And we had determined that our 5-number summary was 2, 49, 51, 60, 53. This is the 5 number. But we need more than that. We need the interquartile range. That would be 60 minus 49, which is 11. And then my fences. Now remember, my fences, I need to take 1.5 times my interquartile range, 11, which is 16.5. And that has to get subtracted from my first quarter and added to my third quarter. So 49 minus that 16.5 is 32.5. 60 plus 16.5 is 76.5. Now it says find the values for your Q1, M, and Q3 and draw vertical lines. Okay, so my Q1 is 49, which is about right here. So I'm going to draw a line because the number line's already on here. 51, I drew a vertical line, and then 60. This is going to enclose them in a box. What that really means is just connect the edges of the lines. Then it says draw a number line long enough to include the maximum and minimum values. We inserted the lines. It says label the lower and upper fences. So the lower fence is here, 32.5. The upper fence is here, like 76.5. It says draw a line from Q1 to the smallest data value larger than the lower fence. Well, the smallest data value larger than the lower fence, bigger than 32.5, is 43. So we'll draw a data value to 43. And bigger than the upper fence is 63. It's not very big at all. It doesn't get to the fence. It says anything that's outside of the fences gets marked with an asterisk. Yes, these are called whiskers, by the way. Sometimes it used to be called a box and whisker plot. Now it's just a box plot. Anything outside the fences is an asterisk. There's nothing bigger than 76.5, but this 2 is definitely smaller than 32.5, so what do? You mark it with an asterisk. And that's it. And sometimes these are like above the number line. I tend to like to put them on the number line because it's easier to see, but it's the same as if you moved this all up from the number line, it would be the same thing. And we will finish 3.5 in the next video.